This is why nuclear energy is bad. Just kidding, it's not, because that's from a bomb, not a reactor. The two are very different, and the way the media portrays nuclear energy is unfair. Nuclear energy is actually a safe, renewable form of energy that is very beneficial to society.
A nuclear reactor works by first having the reactor contain enriched uranium atoms. Then, a neutron is shot into a radioactive uranium atom, and the uranium splits, causing the other uranium atoms to split as well. This reaction heats up water, and the water then becomes steam. This steam moves turbines, which allows the energy to be used by us. However, waste is generated in this process, most of it being uranium, and it is highly toxic and must be stored away. This is where half-life comes in.
There's a lot of talk about half-life, but what exactly is it? Half-life is the time it takes for half of a radioactive element, say uranium, to decay into another nuclide. The more unstable the element, the shorter its half-life. Half-life is quite relevant to nuclear energy because it determines how long it takes for a radioactive element to transition into perhaps a less radioactive element. Thus, by knowing an element's half-life, we can find out how long we can use certain elements as the sources of nuclear energy. In addition, say we know the amount of a radioactive element currently available, the half-life, and the time elapsed. We can then figure out just how much of that radioactive material remains, and thus we can determine how long they'll remain useful, or how long nuclear waste stays radioactive. In doing so, we can better devise strategies for the management of nuclear reactors and the management of nuclear waste.
There are two types of nuclear reactions, fission and fusion. Fission is the splitting of an atom and can occur when an atom undergoes radioactive decay. In fission, the nucleus of an atom splits, leaving some nuclides and neutrons. This reaction releases a lot of energy which can be harnessed. Fission is what is used by reactors to create energy. It works because a neutron is fired at the nucleus of an element, making it unstable. Then, it undergoes radioactive decay, which releases more neutrons and starts a chain reaction. The chain reaction can be controlled using control rods, which is one difference between a bomb and a reactor. Reactors have them to prevent the chain reaction from getting out of control. Now, let's look at an example of fission. You have an unknown element, which combines with one neutron. If that turns into barium, krypton, and 3 neutrons, we can figure out what the original element is by doing arithmetic using the atomic masses and the atomic numbers of the parts. We can see that the original element was meant to be uranium-235, which is commonly used in fission reactions. Now on to fusion, in which multiple nuclei come close and collide at high speeds. The elements are fused, in order to create heavier elements. This produces a lot, more than fission energy, and is used as a power source in the core of stars.
Nuclear waste is one among other problems that can arise with nuclear energy, such as nuclear reactors being the target of terrorists, the small chance that there might be a meltdown causing a disaster, the initial cost being high for nuclear reactors, and not every country having access to uranium. However, with these disadvantages come advantages as well, such as the reactor not giving off CO2 or smog unlike coal and oil, and how the reactor is able to produce energy almost all the time unlike solar or wind energy, and it's incredibly safe. It is affordable in the long run, and it doesn't eat up fossil fuels. Nuclear energy is safe and is one of the better choices when it comes to energy. Unfortunately, due to social stigma from nuclear bombs, nuclear energy isn't as prevalent as it should be. However, some countries like Japan and France use nuclear energy predominantly, and it is very successful.
We put the clear in nuclear.